Good afternoon, everyone. My name is Pam Schwann, and welcome to the Mining and SMR Panel session. I'm president of the Saskatchewan Mining Association, and that represents the mining and exploration companies that operate in Saskatchewan. They're global leaders in providing the world with food and clean energy security through the production of potash and uranium. Personally, I'm a geoscientist who's had the privilege of working in many areas of Saskatchewan and across Canada, and with many community leaders in northern Saskatchewan throughout my career. I was born and raised in Saskatchewan, relocated to Ontario for about 5 years, and had the opportunity to work with the Geological Survey of Canada. Then I came back to Saskatchewan, lived in La Ronge for 10 years, before coming full circle back to Regina. I'm also the mother of 2 beautiful young adults that are 20 and 17. I'm really pleased that you are joining us today from wherever you are situated. I'm sorry that we can't be together in person, but we're doing what we can. I'm participating from Treaty 4 territory, the original lands of the Cree, Ojibwe, Saulteaux, Dakota, Nakota, Lakota, and on the homeland of the Métis. Many of you are joining us from other parts of Canada, the traditional lands of other First Nations, Inuit, and Métis people. Thank you all for joining us here today. I wanted to provide you a little bit of a description of our panel. Our industry panel on mining will discuss the potential benefits of small modular reactors, and I'm just going to refer to them as SMR, to energy intensive industries, including the mining sector, which includes the oil sand operations. Notably, how SMRs can be a part of the solution to significantly reducing greenhouse gas emissions by providing clean, baseload, and reliable energy source. A step change in how the sector can move towards net zero emissions while continuing to provide the world with the products they need. I'd like to recognize our sponsor for this session. Our session is made possible with the sponsorship from Ontario Power Generation and Global First Power. I'm really pleased to be joined today by 2 panel members, and I'd like to introduce them right now. Firstly, I'd like to introduce Amar Jolly with us from the panel. Amar is the Global Director of Nuclear Energy at Hatch. He's a professional engineer with almost 20 years of progressive and diverse experience in the nuclear industry. Amar brings in-depth experience with both the owner-operator and design agency construction management perspective, and has firsthand knowledge of the intricacies that are required to create collaborative project success. So welcome, Amar. Our second panelist is Eric McGoey, Director of Remote Generation Development with OPG, one of our sponsors. Eric is joining us from Toronto, but he was born and raised in Thunder Bay. But Eric and his wife have made Toronto home since 2002. He loves public policy, basketball, election campaigns, so it's been quite an interesting last quarter for you, Eric. Cooking, reading, cycling, and his kids, but not in that order. Eric has worked in the Ontario government for over a decade as both a civil servant and a senior political advisor, and in the resource sector since 2012, focusing on sustainable resource and community economic development, energy, land use planning, and Indigenous partnerships. As a volunteer, Eric serves on the board of Cycle Toronto, an advocacy group that promotes cycling and safer streets for all road users. Eric graduated from Lakehead University in Thunder Bay in 2002 with an HBA in English and a BA in history. So good afternoon to you both, and thank you for being here to share your knowledge and experience with the delegates. Before we get too far along and start in the panel, I know a lot of people are interested in the gamification code. And so for those of you collecting the code, this session is Mine 20. So I'll enter that into the chat room as well. I'd also like to encourage people, if they have any questions as we go through our conversation, and we don't have any slides, it's all really conversation approach that we're taking. Please enter them either in the Q&A or the chat, and I'll be looking at that throughout our discussion. So we're just going to start off by asking both Amar and Eric to talk about their backgrounds a little bit and how they ended up in the positions they are right now. So you know a little bit about them and the experience that they're bringing to this panel. So Amar, we're going to start with you.
Great. Good afternoon, Pam, Eric, and everybody in cyberspace. Thank you for having me. I'm really looking forward to our discussion. I'll start off a little bit about Hatch and then how I ended up at Hatch. For those who don't know Hatch, Hatch is an employee-owned global professional service firm that specializes in engineering, procurement, and construction management. Global headquarters is in Mississauga, Ontario. We serve 3 main sectors: mining metals, infrastructure, and energy. Our nuclear power group is obviously part of our energy. But what's really great is that our sectors all work really closely together, and we're able to draw on the collective experiences and being able to work in different aspects all around Hatch. In nuclear, we serve the entire nuclear fuel cycle, from supporting the uranium mining operations, processing of that, of the uranium, fuel development. Obviously, we support the nuclear power generators. And then on the back end, supporting nuclear sustainability with processing and management of waste, and then back into the ground with long-term storage. I've been with Hatch for about 7 years. Actually, this week is my 7-year anniversary, but as Pam mentioned, 20 years in the nuclear industry. Previously worked at Ontario Power Generation and some other engineering and construction firms.
Thanks. So Pam was nice enough to give me a longish introduction, and so I won't spend a lot of time talking about sort of how I personally got here, because I think maybe the more interesting question is, how did OPG get here? Talking about SMRs, talking about mining, talking about making power off grid. Because none of that is necessarily obvious when you look at the history of our company, formerly Ontario Hydroelectric Corporation of Ontario before that. I mean, we've got a very long history making power for the grid. About half of the electricity produced in Ontario comes from Ontario power generation facilities. And here's where I'll mix the personal and the corporate. When I first joined OPG about 6 years ago, people were already talking about SMRs, and there was a fair bit of excitement about them. But I think there was a fundamental question that nobody could answer at the time. You would have a vendor come in, they would talk about their fuel, they would talk about their inherent safety, they would talk about the market. And if you said to them at the end of this, really interesting pitch, great, how much does it cost and when can I get one? There were not clear answers to those questions. And I think OPG realized then that we had to play more of a leadership role in the development and deployment of SMRs. And that's true both on grid and off. So just on Friday, for example, in Ontario, in the Durham region, there was an announcement that OPG is going to proceed with the planning to use the existing site license and environmental assessment that we have for the Darlington new nuclear site, and use that to look at siting Canada's first on-grid SMR. So that would be a small modular reactor that would feed in power to the electricity grid, as we do at our 66 hydroelectric generating stations, our 2 nuclear stations, our biomass facility, our solar facility, and so on. Off-grid, though, is newer for us, and that's what we're doing at Chalk River. And I'll talk more about it later on in our panel. I'm sure we'll have more chances. But I think this is really an opportunity for OPG in many ways to play the role of the honest broker, where we are doing a commercial demonstration of something that we think will fit really well in the market for mining companies and resource extraction companies in particular, for communities maybe further down the road, and that we think this is our chance not just to contribute to the hype around SMRs, but actually to demystify it a little bit and make sure that we can answer those really good questions about when will it be ready and how much will it cost, so that we're not just talking in marketing terms, but we're talking in real commercial terms about providing alternatives to diesel generation off-grid.
Great, thank you, Eric. That was a great introduction of why OPG is in the space that they're in right now, and I like the term that you used to demystify what's happening. But what I'd like to do is maybe take a step back and talk a little bit about why is the mining sector maybe one of the potential top users of SMRs and that. And so Amar, I'm going to start off by asking you if you can maybe talk a little bit about what SMRs are and why mines might consider them a good option for generating power and potentially heat at their sites, both remote and on-grid.
Yeah, for sure. So, we're really excited about SMRs and what they can do for, industrial and remote communities, as well as on-grid applications, as Eric was just mentioning. We actually got into the SMR business about 10 years ago, a dozen years ago, and a lot of reasons because our mining clients, and we service a lot of mining clients around the world, particularly here in Canada, and a lot of our mining clients were asking us to explain, help demystify what SMRs are for them. And we've done quite a bit of work in this area, originally doing some work for different mining companies, to working with the Ministry of Energy in Ontario, the CNSC, and trying to look at deployments and how they can, how SMRs can be deployed in those situations. We think that, we work with mining companies all the time to set up their power and energy loads and look at different ways of supplying that. And SMRs have, over the years have really become part of the mix. So, what is an SMR? A lot of people are familiar with the large scale installations, at OPG's Pickering and Darlington, for example, or Bruce Power. And they're different. SMRs, as the name implies, are small. So they're smaller than these different than the ones that were commonly used, but it's really in the M and the R. So modular is the key difference here, where the idea is you're building these smaller reactors in a factory setting. You're modularizing as much as you can, almost mass producing them, so to speak, so that they can be deployed out to different locations. And then, obviously the R is the reactor, and it's really, different types of reactors. Some of them are good for different applications, and we can talk about that a little bit more. But the idea is that you're building these, in a factory type setting. You're deploying them out, and you're able to get your economies of scale by kind of sending them out to different locations. It is to replace some of the traditional forms of generation, and some of the benefits are, if a lot of remote mine sites, for example, are heavily dependent on diesel. So, looking as we are looking forward to a greener world, potentially replacing that diesel, complementing different hybrid power systems that may be implemented by different mining operations, and really trying to, further that cause and be leaders in that sector. I think that's the greatest benefit of SMRs to the mining industry.
Thanks. I know in Saskatchewan, a lot of our remote mines, they are still grid connected, but they have backup diesel, which they absolutely need, because the transmission lines are so long that in the summer, the lightning strikes take them down regularly. And so we have, even though they're connected on the grid, there still is a lot of disruption. And so, I think the potential too in remote is that it allows that flexibility and that independence that you would have if you were not necessarily tied into those long transmission lines. And, one of our other major types of mines in Saskatchewan is the Potash Sector, which is a very energy intensive. There's a lot of drying that goes on. And so I gather that some of the different reactors have different benefits in terms of whether they're applied for heat or strictly for power generation.
Yeah, that's right. SMRs gets this kind of label where it's, there's one SMR and it's one size fits all, and that's far from the truth, right? There's many different sizes, from the very small modular reactors to utility scale. So there's different sizes, and then there's different types. Some are shrunken down versions of, the larger counterparts that we already know, like a pressurized water reactor, or different, like our CANDU technology, heavy water reactor that's shrunken down. But some of them are using different forms of uranium fuel, either molten salt or trisol, and some have different characteristics. All are good for producing power, but some may have better characteristics for them for downstream applications, or if the mining or the industrial application is looking for different benefits than just power, they may be looking for steam, for example, where, you know, some may be a little bit better to supply just steam loads and, you know, really offset how they're producing steam now in terms of how you can use an SMR. So I think that's a key difference, is that there is, or one key takeaway is that there isn't just one SMR and you go and you want to purchase one. There's different types, different sizes that fit different applications.
And I know as we are, as a mining sector, we're committed to reducing our greenhouse gas emissions, and I know that would translate over to the oil sands as well. So those steam, particularly a lot of maybe the generators that are focused on steam would be a enhancement to the oil sands sector and reducing their greenhouse gas emissions, because with the carbon pricing, any reliance on diesel or fossil fuels is going to be increasing your cost and affecting your global competitiveness. So, you know, I think that's really where there's a lot of interest from the mining companies. How can they reduce their greenhouse gas emissions, provide cleaner products, and reduce costs all at the same time? And remembering though that we've got to be able to bring in SMR at a cost competitive price as well. So maybe on that point, Eric, I'd like to turn to you to maybe talk a little bit about some of the leadership activities that OPG is taking, particularly at the Chalk River project that you're looking at commercialization of a SMR.
Yeah, absolutely. Thanks, Pam. And I guess I'll back up with a little bit of context from, I think, the question that you asked Amar, because I think it leads directly into what we're doing at Chalk River. And that's if you think about mineral deposits in Canada right now, most of the deposits that are located relatively close to our transportation infrastructure, like roads and rail, or indeed electricity transmission infrastructure, a lot of those resources have already been exploited or depleted and might be coming to near the end of their life cycle. And so when we think about promising new mineral finds, often we expect that those are going to be at some distance from infrastructure, both transportation and energy infrastructure. And so I think that is where some of the appeal of these, particularly sometimes referred to as VSMRs, very small modular reactors, could play, because you could imagine essentially eliminating a lot of the logistics around the transportation of diesel fuel. So when you look at the project that we are doing the commercial demonstration of at Chalk River, for example, that reactor is designed to be fueled once, run for 20 years on that load of fuel. And that means that single load of fuel over that 20 years provides the equivalent amount of energy as 265 million liters of diesel. So to your point, Pam, you think about the greenhouse gas consequences of eliminating that 265 million liters that you would otherwise have to burn. Absolutely, that's a huge factor. If it were not for climate change and the need to drastically reduce the amount of carbon we're putting into the atmosphere, I don't think people would be talking nearly as much about SMRs as we are. That's the challenge. And SMRs are one of the tools around, along with other renewable or non-emitting forms of electricity. And so that's really so there's the environmental piece, but there's also just the pure logistics of having to ship 265 million liters of diesel over a 20-year period. That's significant. And there are some unpredictabilities in costs that you're going to have. Maybe you know what you're going to be paying for diesel for the next 5 years, but you know those years 15 to 20 are a big question mark on your risk register. Whereas moving to an all-in fixed cost with an SMR could be quite interesting. So what OPG is trying to do at Chalk River really is to work with one of the leading SMR vendors who have one of the more interesting technologies, because to Amar's point, there's a lot of different vendors and a lot of different technologies. And so Chalk River Laboratories, as part of Canadian Nuclear Laboratories, essentially hosted a competition on their site. And with the closure of their research reactor, you know, they have this incredibly talented team of scientists, researchers, PhDs, and with a lot of experience on nuclear. And they wanted to add new life to their site, reinvigorate it with a vision of a clean energy park that would look at hydrogen production, small modular reactors, and so on. And a vendor called Ultrasafe Nuclear Corporation has a really interesting technology that they call micro-modular reactor. And so fundamentally, that reactor uses fission process to generate heat. Most SMRs, there was a question in the Q&A, how an SMR works. Fundamentally, you use the process of fission, you split atoms, that generates a lot of heat energy, and you can use that heat to do a number of things. You can use it as process heat, for example, make steam, which would be very useful in the oil sands, for example, or you could run that through a turbine and make electricity. So the MMR unit that we're building at Chalk River, is a commercial demonstration, produces about 15 megawatts of thermal energy. And when you convert that to electricity, you get about 30% of that. So you get about 5 megawatts of electrical energy. And that could be used, for example, to power a small mine or a town of about 5,000 people. And really what we're attempting to do at Chalk River is prove that commercial model and make sure that we're cost competitive. So Pam, to your point, this isn't going to work if it's too expensive. And I really think that there's the two largest obstacles to successful deployment of SMRs in Canada, and it's been touched on in some of the previous panels. One is cost. We have to be cost competitive against some of the alternatives. And the other is community acceptance. And we have to do a really good job talking to communities and understanding community concerns and aspirations and priorities if we're going to get buy-in on using this tool.
Thanks, Eric. You know, we've got a few other questions in the panel, or in the Q&A, so I'm going to go to that, and then we'll go back to some of our discussion that we had. So one of the questions was, how do SMRs work? And I think, Eric, you went over the process a little bit in terms of the fission and the heat generation, and then how that can be also changed to power. But Amar, I'm wondering, as the engineer in the group, if you wanted to maybe provide some additional information on that.
No, Eric did a very good job. It's essentially that, you know, as most power generation goes, the goal is to spin a turbine. You can do that by a number of ways, which is, you know, burning by fossil fuels to heat water to create steam, so you can spin a turbine. In this case, we're using the properties of uranium and the fission process to create heat, which boils water, and that creates steam that spins a turbine. So that's a real good way. The one big difference between burning a fossil fuel and using uranium is energy density. And Eric talked about that, where, you know, a small, you know, uranium pellet has the ability, and I forget the exact numbers, but I believe it's one small pellet can power a home for a year or 2 years. Whereas, you know, using fossil fuels would be many times more, you know, oil or natural gas, you know, to do that. So the energy density of uranium is very, very high, and you get a lot of power out of uranium. And so that's one of the big benefits for using nuclear technology.
We had another one. It seems to have disappeared from my chat, but it was, what is the size of the small modular reactors or very small modular reactors? And Amar, maybe I'll put that one in yours because I've got another one for you, Eric.
Sure, it makes sense. So it's a good question. So I mentioned before that there's a range. The VSMRs is that, you know, very small modular reactors, I would say are in the, you know, there's no commonly accepted definition, but it could be 1 to 2 megawatts. In some cases, there's the, you know, ultra small, which could be in the, you know, kilowatts range, but generally it's in the 1 to 2 megawatts. And then they range up to, you know, utility scale, which would be around 200, 300 megawatts. And, you know, that would be replacing, you know, a natural gas plant, for example, on the utility scale. So they really do range in size, depending on the application.
Sorry, Pam, you're on mute.
There we go. Now you can hear me. Okay. I was just going to refer people as well to NRCan's roadmap on small modular reactors. It's got a lot of really great information in terms of, you know, what would industry be looking at for size, what would service a community, you know, typically of X number of people. But one of the great things I think and promising aspects of the modular reactors is that you can actually, you know, put them into different modules. So maybe it's a 10 megawatts, but it grows to 20 by another, you know, adding another 10 megawatts. So it's very much like your 6-pack type of concept where you can build up or build down depending on what your power needs would be. So Eric, the next question I'm going to ask to you is, there's a question, we might have gotten to this later, but it's an important one. I want to make sure we talk about it, is how does mining and SMRs connect to opportunities for Indigenous businesses? And maybe just I'll start by providing a Saskatchewan perspective about the importance of Indigenous participation in the Saskatchewan mining sector. Particularly our uranium mines and gold mines in northern Saskatchewan have really long been business partners with Indigenous communities. And every year we see significant employment. Over 45% employment at the uranium mines are by residents in northern Saskatchewan, which are primarily Indigenous. We have well over $300 million a year in business contracts that go to Indigenous-owned businesses. Most of them are at-depth corporations in northern Saskatchewan, but we're seeing growth in the potash sector as well in terms of the number of Indigenous businesses that are engaged, the initiatives that the companies are taking to make sure that their workplaces are inclusive and that there's capacity built into the Indigenous communities so they can be the workforce of the future and also be the Indigenous business suppliers of the future. So with that, Eric, I'm going to turn it over to you to maybe talk about OPG's experience in Indigenous engagement.
Thanks, Pam. It's funny, I actually thought there was another question from the chat you were going to throw me, which is another good one. So I hope I get that one later. You'll see in the Q&A. But yeah, to your point and James's point about what are the opportunities? I think there's a couple of different ways to answer the question. So let me come at it a couple angles. One is that I think we need to acknowledge upfront that Indigenous communities so far have not benefited directly and economically from the nuclear sector the way that communities like Durham region or the Kincardine region or even Deep River area have benefited from nuclear. That is, a large asset that you can have on your tax base and a lot of good paying jobs. Now, I say most Indigenous communities haven't benefited. There have been great success stories coming out of northern Saskatchewan and the uranium mines and the services sector there, with some really neat companies that have sprung up, Indigenous owned companies that have benefited. But I want to acknowledge that nuclear is not necessarily the first partnership that many Indigenous economic development corporations might want to put up their hand to partner with. That we have a lot of catching up to do to have the kind of attractiveness that, say, the renewable sector might have right now, and we're not blind to that. So one of the things that I would note, for example, is my title doesn't have the word nuclear in it, right? It's remote generation development, and that's because one of the things I love about OPG is that if you can make power with it, we do. Right? We've got biomass fueled facilities. We have natural gas fueled facilities. We have 66 hydroelectric generating stations, a solar facility, 2 nuclear plants. We had a windmill that we were using to kind of test out to see whether we might want to get into grid scale wind, and ultimately decided not to. So we're not showing up because we've only got one thing to sell and we think you should love it. We're interested in having conversations with communities about what fits their needs. But the other piece that I think is really important here, and one of the reasons that I'm so excited to be working on this project OPG, is over the last decade, every single greenfield that is brand new generation project that we have built in Ontario has been done in partnership with local Indigenous communities. So we've done 3 of those partnerships on the hydro side of the business, 1 on the solar side, and we haven't done any yet on nuclear because our nuclear plants were built much longer ago. This, I think, is an opportunity for us to take that track record of Indigenous partnership and equity ownership that provides long-term ownership and an income stream for communities that they can use for community priorities, they can borrow against because of its predictability, and we can apply that same model that served us so well in strengthening relationships and apply that to the nuclear side where communities might be interested. So you could imagine that, for example, if you looked at the Global First Power project, let's say we get through our commercial demonstration, we prove the economic model, and we sign a deal with a mining company in, let's say, Northern Ontario, for argument's sake. We might, when the mining company is going to be moving ahead with their project, and we would probably approach the local First Nation in whose traditional territories we were, and talk to them about whether they were interested in partnering with us on the SMR that was going to provide the power for the mine site. And through those, I think, early commercial arrangements, we might at some point get to a point where communities are comfortable with nuclear, trust SMRs as a safe and non-emitting form of energy, and might start to say, what if we use this to power not just the mine, but our community as well? And so that, I think, again, we can't get too far ahead of ourselves, one step at a time, but I think that is a lot of the promise that we're talking about here in terms of Indigenous community involvement. Not just training, not just contracting opportunities and procurement, although that's all really important, not just capacity building as we're going through the AA process, but actual meaningful partnership and ownership.
Great, thanks, Eric. You brought up a couple, I think, of really important points on there, both in terms of the equity, but also I think maybe a lot of people aren't thinking about, or you know, if they hear a power generation on the mine site, they assume that the mine might take the responsibility rather than having, you know, a company that's got the expertise come in, deliver the modular reactor, look after it over its lifetime, and then take it away at the end of the day. So the whole concept of who is actually providing the power is really interesting. Amar, I'm going to ask, we have more questions in the chat room, and they actually follow a little bit of our script. So I'm going to pat myself on the back for thinking about some of these questions. And it's about integration of SMRs into mine sites. So the question is about, can SMRs be integrated into an existing mine site already? Or do the mines have to be built around an SMR? But we're also maybe going to tie it into how SMRs can be used and integrated with renewables. So I'll start with you, Amar, and then I'll maybe go to Eric on the integration with renewables.
No, for sure. I think the quick answer is yes. I think it can be put into an existing mine site. You know, I think the wrong criteria might be the life of the mineral deposit. You know, if you only have a short period of time, you're probably not going to spend the money to make a major change to how you're producing power. But that's not to say that it wouldn't make sense, given how even Eric, how you mentioned that, you know, a company might want to come in and spend the money. There's a question here about financing an SMR here as well that I'll kind of touch on. But an independent company might want to take that on and say, you know, a developer with an operator with, you know, community partners, maybe different partners want to come in and they want to set up a power company that would deliver power to a mine site or a remote community via a power purchase agreement. And, you know, it's just like you're hooking up to, you know, your own dedicated grid, so to speak. So I think, yeah, an existing mine site, yes, is totally possible. I think the longevity of the mineral deposit is definitely a consideration. You know, but when you're planning out your mine site, usually you're planning, you know, quite a number of years in advance, possibly even a decade or more. And that's really where, you know, you're going to start to figure out in a greenfield situation, what are the operations that I'm going to be looking for? How can I plan out my power? You know, that's where you might get into the discussions of, okay, I want to put an SMR, and really it needs to be part of a hybrid solution. I think, you know, there's a lot of benefits that nuclear can provide, or an SMR can provide. Eric, you touched on a lot of them. You know, in terms of, you know, transportation logistics, you know, you only have to really worry about it when you're setting up. You know, the ongoing logistics of, you know, fuel. And as you rightly mentioned, a lot of our resources are going to be in probably more inaccessible, or traditionally hasn't been accessed before. And so, you know, it may be an ice road situation where you're dealing with trying to plan your logistics around the weather and ice roads. And if you can eliminate some of that vulnerability where you have your power, it's there, you can now think about, okay, what else can I do? And one thing that SMRs could do is potentially make you think about, well, what else could I do? Could it power a nearby community, as you talked about? Yes, I think there's definitely discussions that could take place there, but you could also electrify a lot of your mining operations. You could also, you know, do more processing at site, which would cut down on your transportation costs. You know, if you're sending less raw product and a more refined product, you're having to spend less on your transportation of sending things out to be processed in a major center. But I think that all has to work in conjunction with your overall, you know, what your plan is for your mine site, what your needs are, you know, and looking at what your total hybrid solution is. And so we're already doing that with a lot of different mine sites now. You know, a lot of mine sites might have, you know, solar and wind and a diesel with some storage, and combining that into a microgrid. I think, you know, replacing potentially diesel with a SMR is a great first step, but it's got to be part of a larger renewables. You know, like anything, you're going to need a backup to even your SMR, but you're going to need a backup. So I think it's really in that upfront planning that you have to do and figure out what and how everything kind of plays together.
We still have more questions. So, Amar, did you want to talk at all about the financing part of that? Are you familiar at all?
Sure.
And Eric, if you are, just give me a wave or a thumbs up, and I'll get you in on this too.
Sure, I touched on it a little bit. You know, there's lots of different models that's being talked about right now. One might be, you know, a special purpose vehicle or an operating company coming together that might put up the money, you know, to finance and get all the upfront costs covered, and then they'll get paid via a power purchase agreement with, you know, an industrial site or a community or a combination thereof. There might be a situation where the actual mining company or industrial company might want to take it on themselves. You know, a few years ago, I probably didn't think that was true. More lately, I think that there's companies out there that say, hey, you know, we do complex things all the time. We might be wanting to try and take this on, potentially. That might be an area that comes up. But I think that's where it is. And I think the key is having, you know, the off-takers, having your plan, having that set up, and that would set up your financial model on, you know, how you would pay for this. And, you know, it would become just as easy as, you know, the goal is it would just be as easy as you're buying and financing other equipment and other parts of your mining operations.
And we're running up into a little bit of a time crunch. We have some more questions, but Eric, you had already talked about OPG and how they have worked with in terms of equity partnerships. Could you go on to just maybe a little bit more detail in case that's the type of model that could be looked at for SMRs, as well as maybe some of the other power partnerships that OPG has done?
Yeah, for sure. So the we have done a range of partnerships, you know, depending on the communities and what they're looking for. But essentially, what happens is that the local Indigenous community who partnered with us on the project might receive or might acquire an ownership stake anywhere from probably 10% on the low end to maybe 33% on the higher end. It's varied project to project, where they would, in many cases, borrow the funds to purchase the equity and then repay the cost of that borrowing through the revenue stream that comes once the operations are running. What's really neat about that is because of the long life of these energy projects, when you build a hydroelectric facility, that's going to run for 50 to 100 years generally. And many of those, if you rate regulate those operations, for example, that's a very predictable cash flow that you're going to get. And so what we've seen communities do is some communities have tried to accelerate the paying back whatever they borrowed for the initial equity acquisition, so that they can then free up more money that would be available for other community priorities. And then once that they do have that steady income stream, sometimes they will borrow against that so that they can accelerate their own community ambitions, whether it's around education, healthcare, economic development. They have the opportunity to build new facilities, for example, or provide training for their membership. So it's been a really useful model that we've seen on projects in Northwestern Ontario, Northeastern Ontario, and then also in the Southwest.
And Eric, I didn't allow you to talk about the integration of SMRs with renewables, which I know is something that you've talked to me a little bit about. It's not only one source of generation. So did you want to maybe expand upon that?
Well, I will, and I think it actually touches on another question that was in the Q&A as well, which is essentially, why would you try to help the oil sands instead of just replacing them? Right? I'm paraphrasing, but I think that was essentially the question. And so I'll answer all of that at once by saying, in the energy sector, we have a really bad habit of talking to each other a lot and not doing a good job talking to the outside world. We have another very bad habit that I've seen in the years I've been in this sector, which is bad-mouthing each other's technologies, bad-mouthing each other's fuels. So the renewables folks say, oh, nuclear is the worst. And the nuclear people say, oh, fossil fuels are the worst. And I frankly don't think that helps us very much. I think we need to acknowledge a bunch of things. Different geographies, different jurisdictions have different preferences and different endowments. So for example, Quebec, BC, Newfoundland and Labrador, Manitoba, they all have such geography and tradition, long economic benefits from hydroelectric development. I can't see them backing away from hydro and deciding to go nuclear anytime soon. So when we're looking at SMR development, we're looking mostly at places that don't have those same hydroelectric riches. Similarly, I think you look at producers in the oil sands, and they're not necessarily ready to shutter their operations. They understand that climate change is a real thing, and they certainly need to dramatically decrease the emissions that they have from the development of those, or extraction, pardon me, of those resources. But they still believe that fossil fuels can be a transition fuel, particularly in emerging markets. And fair enough. That probably makes a lot of sense. It would be significantly disruptive to the economy if you went from full production to no fossil fuel production. And so I think anything we can do to help reduce the footprint of extraction is a social good, even though we might also have ambitions of maybe more aggressively electrifying the transportation sectors, for example, which might reduce some of the demand. So what I would say is, Amar talked earlier about energy density. It's a huge, huge point. That is to say, is it theoretically possible to deploy windmills, solar panels, and battery storage at such a scale that you would not require things like SMRs? And the answer is, in most cases, yes, that is theoretically possible. However, because of the intermittency of those sources, because sometimes the wind doesn't blow or the sun doesn't shine, you need to overbuild so much that the economics aren't there. And looking at a base load source of electricity, something like hydro that runs almost all the time, or an SMR which can run continuously for years and years, that has a lot of advantages, and that's why people are looking at complementing intermittent renewables with a backstop of baseload power from something like an SMR.
Terrific. Thanks, Eric. And we are running short of time. I have one more question that somebody's asked me. So I'll just say this is about, does the SMA have any initiatives to help educate our mining members about nuclear solutions and SMR? Saskatchewan is right at the front end of the whole nuclear fuel cycle with exploration and mining of uranium and doing a very safe and environmentally sustainable job of that. But we do have a number of initiatives that we've identified in the SMR action plan that will be released later this week. They involve workshops with our members. They involve talking about careers in the nuclear sector. So we do have some, and I can send that link into FNPA after this for distribution if that's helpful. So, but again, the SMR action plan is to be released later, and all the chapters from various organizations that have contributed to the roadmap would be available there. So I will leave it at that and just ask our panelists right now. Well, I don't think I can ask you for any final comments because we're over time right now. So what I'd like to do is I would like to thank you both, Eric and Amar, for joining me today to discuss and explore how SMRs could be used at industrial sites like mine sites as sources of clean energy and heat and significantly reduce GHG emissions. And I just wanted to mention that we know the oil sands has made great strides in reducing their emissions intensity. SMRs could maybe further help that and keep the important fossil fuel production that benefits many across Canada ongoing as a transition. We also want to make our products more sustainably sourced and continue to provide opportunities for communities to benefit. So Amar, best wishes to you with your work at Hatch and advancing nuclear solutions across the world and to the mining sector. And Eric, continued success on your work with OPG as a climate change leader in both traditional reactors and SMRs. We really look forward to the results of your project at Chalk River. For the delegates, if you'd like further information, please visit the virtual trade show exhibitors representing utility companies, technology companies, and clean energy organizations, including both OPG and Hatch. And finally, Tenigi, Marcy Cho, thank you to all the virtual delegates who joined us today, and to FNPA CEO Guy Lonechild for including this panel on mining and SMRs in this forum. So have a good day, everyone, and thank you again for joining us.
Thank you.
Thank you very much. Bye.
Bye-bye.